Personal finance practice problem using Excel. Savings account, compounding interest using future value. Prepare to get financially fit by practicing personal finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet, would like to follow along, note that we're down here in the practice tab as opposed to the example tab. The example tab in essence being an answer key. We have the information on the left-hand side. Going to populate that into the blue area on the right-hand side. We're looking at future value calculations. Probably one of the most common examples of a future value calculation, that being related to a savings account and thinking about what the interest or what the amount will be in the account in the future, considering an interest rate that will be applicable. We can have a similar type of calculation with any type of investment, if it was like stocks or bonds or any other kind of investment that we're assuming that will be going up in value, like land or a home, although of course it would not be interest in those cases, but we could still assume an increase in value over time. We did similar problems to this in the past, but we asked the question as to how long it would take for something to double, which is slightly different than just thinking about where you will be at some point in the future if you have an investment and assume an interest rate or annual increase that will compound annually, as we will do this time. So we're going to say the savings account has $5,000 in it. Interest rates are at 4%. Now note, 4% could be reasonable depending on the time period in which you have your money in a savings account. If you're in a time period, as we currently are, where the interest rates have been historically low for quite some time, then 4% might seem high if you put something into a savings account. But if interest rates were to increase, then you might see it 4% whatnot in, say, a savings account. And remember that these kind of rates can be applicable to other types of investments as well. In other words, the method being used could be similar to if you have stocks, although it would not be interest in that case, but you could still assume an increase in the value of the holdings. You could do the same for bonds and so on and so forth. So we're going to say then, how much would you have in years 8? So if you had the money in the savings account, you held it in the savings account, you're getting 4%, which you're being compounding annually in our practice problem. How much would you have in 8 years? Now, most of the time when you have a question like this, people will pull out the financial calculator or Excel, get right to that bottom line answer for it. And that's a great tool to have, but it's useful to then look at the actual compounding. So we're going to start off with a running balance calculation. Highly recommend getting used to the running balance calculation because it'll show you what's actually happening with regards to the compounding of the interest. So I'm going to start off with 0, 1, then we're going to do our autofill function to copy that on down. We're going to select those two cells, put our cursor on the fill handle, left click, and drag that on down. So that's going to give us 8 periods. Let's center that by going to the Home tab, Alignment Group, and Center. Then we're going to be on the investment side of things. It's going to be 5,000 at our starting point. We're not going to simply type in 5,000, but rather take that information from the data. So I'm going to say equals left, 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 and up. There's the 5,000. Then we'll do our calculation at the 4%. We have a 4% increase, so 5,000 times 4% we're going to assume is the interest that we're assuming we're going to keep in the account and accumulate upwards in the future, then applying a growth on the interest rate, the compounding. So this is going to be equal to then the 5,000, right once, up once, times left, 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 that 4%, and enter. We're going to copy this down later, and we will need an absolute reference to do so, but we won't do that yet. We're going to think about that in the future. Then we have the 5,000 plus the 200, which we're going to do this way, equals up 1 plus left 1. There's the 5,200. Let's do this a few more times. Now we have 5,200 instead of the original 5,000 that we're going to be multiplying times the rate of the 4%. So this is going to be equal to right once, up once, times left, 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 up, and enter. So now we got the 208, interest increasing due to the compounding. And this is going to be equal to up 1, the 5,200, plus left once, the 208, giving us 5,408. Let's do it 2 more times, and then we'll go back and copy it on down using the autofill function. So we're going to say this is equal to the right once, up once, the 5,408 times left, 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 up, up, the 4%, and enter. There's the 216. Then we're going to add this up. This will be equal to up once, the 5,408, plus left once, the 216. That gives us the 5,624. Let's do it one more time. This is going to be equal to right once, up once, times left, 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 up, 4%. The 225, this is going to be equal to up once, the 5,624, plus left once, the 225. That gives us the 5,849. Now I'm going to go back and delete what we've done thus far. Do it again, keeping in mind what we need to do in order to copy it on down with the autofill. So let's delete this thing and do it again. And this time it's going to be equal to right up times the 4%. Anything I'm grabbing on this right-hand side, when I'm keeping in mind that I'm going to autofill it down, I'm going to start thinking I need an absolute reference because I don't want that 4% to go down. It's outside the table. I probably need to do that, but I won't do it yet. We'll do it in a second here. This is going to be equal to up once plus left once. Now let's autofill it down one time, copy it down. This would be the same as copying it in this case. Autofill handle, drag it down. And then I double click here. This number doesn't look right. I say, yeah, it moved that down. Shouldn't have done that. I don't want it to do that. I don't want it to do that. But this one did what we wanted to do. So the relative cells look good. So let's go back and say, okay, let's delete these two and do it again. Double click on that 200. We don't want that 4% to move down. That's in cell B3. Put our cursor in B3. F4 on the keyboard, or you can simply type in a $sign before the B and 3, making it absolute. You only need a mixed reference, but an absolute works, telling Excel, don't move that cell down. Don't you move that cell down, Excel. All right. So now we're going to select these two and we'll autofill it on down, putting our cursor on the autofill handle, dragging it down. And I'll be confident going all the way down before I double check it. And then I'll double check this last one, see if it does what we think it should. It looks correct. It looks correct, just like I knew it would. We knew it was going to do. I was totally confident. Okay, so now we get down to this bottom line would be at the 6,843 at the end of the 8 years. And we can see how the interest is compounding, which is useful with regards to the interest table calculation here. Let's go ahead and hide some cells now. So we'll put our cursor on D, and let's scroll on over to G here, even though you can't see it. I think that's a G, if I know my alphabet right. And then let go and right-click and hide those cells. So we got the data input right next to the data. And now let's do the same thing with the future value, which is going to jump right to that end number, but not give us that nice running balance. That's why you probably want to do this one and the running balance together in practice. Would be the ones you'd want to use in practice, and then the tables and the formulas is probably what you would be forced to use from time to time if you're in a test situation, in a school situation. So we're then going to do this. We're going to say this equals the FV, and we can double click on that, or simply say Shift 9, which is all. The more you're away from the mouse, the geekier you are, that's what we're shooting for here. So left, 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 down, and then we're going to say comma. And then we're going to get the number of periods. So the number of periods is left, 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 down, 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 8, and then comma. And the payment, that's going to be if we had an annuity. This is not an annuity. We don't have a series of payments we're putting into the savings account, but only one payment that we're expecting to compound over periods. So 2 commas here, and then we got left, down, down. We shouldn't have gone left, and then up. The 5,000 and enter. I don't need to close it up. I'm just going to say enter. There it is. I think that's the same number, pretty sure, but it's negative. I don't want it to be negative. So let's double click on it. We could put a negative in front of the present value here, or we can put a negative in front of the F, which I like to do, which probably isn't as proper, but it flips the sign of the entire function like so, and I think it's easier to do personally. So now let's do the same thing with the tables. Remember that the tables would really only happen, oftentimes they were great before we had, the computer and the financial calculators and whatnot. But now you'd probably use them in a school setting when you have the maniacal teacher that takes away your calculator and Excel and acts like you're going to work in like a cave with chalk, that you got a rock that's not even got a good point on it that you're trying to scratch into the side of the wall. So then we're going to say that we got 4% and 8 periods. So 4% and 8 periods down here. We're going to say this is going to be the 1.3686, 1.3686, 1.3686. And let's add some decimals so we can see that number. Home tab number. adding some decimals. There's only 4 of them. Notice that the tables are limited in that way. They will be rounded. And we go to the font group, underline, and amount. And let's multiply this out. This is going to be equal to up, the 5,000 times the 1,03686. And there we have it. So there, and this one happens to be exact here. So notice if I add some decimal, I'm kind of curious if I add some decimals and add some decimals. So it's still a little bit off if you add the decimals to it. So remember that a test question can use that. Like if you're in a school setting and you say, look, I am not a caveman. I don't need to use the tables. I have Excel and I'm gonna use it. And then you do it this way and you get the more exact answer. They can still see that and they can say, well, you should have got this 6,843 because we told you to use the tables and you didn't, and you got something different. So we know that you didn't do it the way we told you to do it. And that could be something that they can differentiate on a test question or something like that. So remember, you have to use the multiple methods. 1, so that you can do the test question properly, and 2, so that you can understand what other people are doing if they use a method different than the method that you're using. So let's go ahead and hide some cells again. So we have the column K right next to our data. So we're going to put our cursor on H, left click, and drag on over to J, H to J, let go, right click, and hide. So now we're going to do it with our formula down here, straightforward formula. Future value equals the present value times 1 plus R to the N. We're going to do that instead of just plugging it in algebraically. We'll build our table type of format over here. As we do so, we're practicing kind of doing financial statements or tax return kind of format, which is highly useful in my opinion. So we're going to go ahead and these 2 components we're going to put in the outer column here. Any subcategories we want to put inside with a colon and with an indentation possibly to indicate that it's going to be a subcategory as well and bring into the inner column. So we'll start off with the present value, which is this term right here. Going to put that in the outside. It's going to be 5,000. I'm not going to type it in here, but rather say equals left, 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 up, and enter. And then we're going to do the other side, which is going to be the 1 plus the rate to the n periods. 1 plus, notice I have a colon here, meaning I'm going to pull that into the inside. So I'm going to say 1, and then the rate, I'm going to say rate is going to be equal to, because I'm going to pull it from the cell over here. I could type in 0.04, but I don't want to type it in there because I want to pull it from the data set. I want to pull it from the data set. That's good practice. That's good Excel practice. That's how we should do Excel. And so then we're going to go to the Home tab, number group. We could add decimals to make it 0.04, or we could make it a percentizing it, which isn't an actual word, but I think it kind of should be. We percentized it in Excel. It's been percentized. And then we have 1 plus the rate, and we can use the trusty sum function. Remember that this 1, of course, if we made it into a percent, would be number group percentize 100%. So 100% plus the 4% subtotal equals the SUM. Sum function, gotta know it, Shift 9. I would do it without using the mouse if possible. Up once, holding down Shift, up again. So we have our items here, and then we could close it up, but we don't need to, and just enter. There's the 1. We need to add some decimals. Home tab, number group, decimalizing or adding decimals, which you could call decimalizing it. Although again, that's not a word, but I kind of like it. 1.04%, or if we make it a percent by percentizing it, 104%. Then we're going to take that to the power of n. So it's going to go 2n periods. Let's say periods. And that's going to be 8, which we could type in, but we need to take it from our data on the table to the left, because that's how we do things in Excel. That's how things are done. Home tab, font group, underline. That allows us to run different scenarios if we so choose easily. And this is going to be 1 plus the rate, Shift 9, Shift 6 to the n periods, Shift 9 periods. And hopefully I spelled that right. And this is going to go to the outer column because we finished off this thing now. So now this is going to go to the outer column. We're going to take the 104% to the power of 8. Equals left, up, 104%. Shift 6 gives us the caret, left and up to the 8 periods, and enter. There we have it. Let's add some decimals there by going to the Home tab, number group, and adding decimals. And when I just add a bunch of decimals, I call it decimalizing it. It's been decimalized. And then we're going to go to the Home tab, font group. That's not a word. I know, but it's still, I think it should be. So then we're going to say the future value is going to be here, and we can now multiply these last two out, multiply these last two. This is going to be equal to up, 5,000 times that decimalized thing that we did. And that gives us the 6,843. Adding some decimals there, this should be a more exact answer. There we have it. Now notice that this number right there, the 13685, should be what's on the table. So if I go to the table, and what was it? 4 and 8, 4% 8, and we get 4% 8. We get the 1.3686. So 1.3, and then they rounded it to 4 digits, you can see there. And that's what the difference is with the rounding difference. This is how they got kind of the table, but they cut it off to 4 digits. So then we can unhide this by going to the B up top, left click, drag on over to H, or K, that's a K, right click, and unhide. So now we got the 6,834 from the running balance, 6,842.85 from the future value, which is exact number, the 6,843, which is a little bit different due to rounding because of the tables, and then the 6,842.85, which should be more exact for the actual formula. And then, of course, we've got our running balance to show us the yearly interest that has been accumulated upwards as well. Note the yearly interest is often useful for these kind of calculations because they might have a tax impact as well.